Namaste everyone. Welcome back to our channel. I am your Java programming teacher, and today we are diving deep into a very crucial topic for any serious Java developer, SQL Joins explained with Java examples. Understanding how to effectively use SQL Joins is absolutely essential when your Java applications need to interact with relational databases and combine data from multiple tables. This is an advanced topic, so buckle up. We will cover the different types of joins, their underlying logic, and most importantly, how to implement and handle them efficiently using Java Database Connectivity, or JDBC. By the end of this tutorial, you will have a solid grasp of how to retrieve complex, related data for your Java applications. Let us begin this exciting journey. Alright, let us start with the foundation, the inner join. Imagine you have two tables, say students and courses. An inner join acts like an intersection in a Venn diagram. It returns only the rows where there is a match in both tables based on a specified join condition. Think of it as finding all students who are currently enrolled in a course and vice versa. If a student is not in any course, or a course has no students, those records will not appear in the result. In Java, after establishing your database connection, you would create a statement or prepared statement object, execute your SQL query, and then iterate through the result set to process the joined data. Remember, the result set will contain columns from both tables, allowing you to access all the combined information. This is the most common and fundamental type of join you will encounter. Next up, we have the outer joins, starting with the left join. A left join, sometimes called a left outer join, returns all the rows from the left table and the matching rows from the right table. If there is no match in the right table, it will still return the row from the left table, but fill the columns from the right table with null values. This is incredibly useful when you want to see all entries from one table, even if they do not have corresponding entries in another. For example, you might want to list all students and, if they are enrolled, their course names. Students not enrolled in any course would still appear, but their course name column would be null. The Java code for executing this query is similar, but you must be prepared to handle potential null values in your result set when fetching data from the right-hand table. The right join works symmetrically, returning all rows from the right table and matching rows from the left, with nulls where no match exists. Now, let us put it all together with a practical example involving a full outer join and Java database connectivity. A full outer join returns all rows when there is a match in either the left or the right table. If there is no match, it returns null values for the columns of the non-matching side. While not all database systems directly support full outer join syntax, you can often achieve the same result by combining a left join and a right join using a union operator. In our Java example, we will demonstrate fetching student and course data using a left join, which is more commonly used and widely supported. We will connect to a database, execute the join query, and then iterate through the result set, carefully checking for and handling any null values that might arise from the outer join. This complete program will show you how to set up the connection, execute the query, and print the combined results. As you become more comfortable with SQL joins in Java, it is important to be aware of common mistakes and adopt best practices. One frequent error is forgetting to specify a join condition, leading to a Cartesian product, which combines every row from the first table with every row from the second, resulting in a massive and often useless dataset. Always ensure your on or using clause is correct. Another mistake is not handling null values correctly when using outer joins in your Java code, which can lead to null pointer exceptions. Always check for null before trying to access data from potentially non-existent joined rows. Best practices include using prepared statements to prevent SQL injection and improve performance, ensuring you close your connection, statement, and result set objects in a finally block to prevent resource leaks, and using appropriate join types for your specific data retrieval needs. Remember, efficient database interaction is key to robust Java applications. And that brings us to the end of our advanced tutorial on SQL joins with Java examples. We started by understanding the fundamental inner join, moved on to the inclusive left and right outer joins, and explored a practical Java database connectivity example for fetching combined data. We also discussed crucial common mistakes and best practices to ensure your database operations are robust and efficient. Remember, practice is key. Try experimenting with different join types and scenarios in your own Java projects. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more advanced Java programming tutorials. Your support helps us create more valuable content for you. Keep coding, keep learning, and I will see you in the next video. Dhanyavad.